So this is D-Day number 2. This is our second D-Day. Let's look at number 2 here. It says at the top of the screen, but number 2. So Aaron just inherited $5,000 from his grandmother. He plans to invest the money, not touching for 20 years. On the table below, assuming he invested it in treasury bills at 6% interest, compounded annually. Okay, so we're going to be starting with 4,000. And it is compound interest, and it is 6%. So that means our multiplier is going to be 1.06. So we can continue to multiply by 1.06, okay, each of these. And I'm going to actually add a 20 on here because we eventually want to get to year 20. So we went to 12, and I'm going to add a year 20. So I'm going to do this a little bigger. So I'll put year 20 down here. Okay. So instead of trying to do this and keep timesing by 1.06, I can go to the y equal on my calculator and put in the equation. And the equation I'm going to put in, I'm going to write it for another C. So this is going to be y equal 4,000. That's our start. Our multiplier is 1.06 to the power x. And so that is the equation that I'm going to be entering in here. So I'm going to go 4,000 times 1.06 raised to the power x. And remember, raised to the power is right here, and this is the x right here. And then I'm going to push enter. And if I want to see the table, on the graph button is the word table in blue. So anytime you want anything in blue, you're going to press the blue second, and then the button you want. And oops, I must not have pressed it. Get it back on again. Okay, so you're going to press the blue second button and the table. And let me see, I have changed my window here. So your window should default automatically for the table set. Yours probably should be starting at 0 going by 1s. Okay, so what I just did is mine was going by like 0.1s because I had changed it in the past. This button here, table set, second, and this button table set, the word window on it, that allows you to start your table wherever you want and go by whatever you want. Okay, normally you don't have to do that. Okay, so I'm going to come over here because sometimes these numbers are bigger than what you're seeing here. So that one's 4,000. The next one's going to be 4,200 and 40. The next one is $4,494.40. The next one is $4,764. And for this, I am going to, let's see, right on. No, I can't write on the picture. So what we're going to be doing is we're going to be looking at the 0.064. So the 0.06, you're going to stay at 6 cents to go up to 7 cents, but the 4 is going to keep it as 6 cents. And then I'm going to go to 12. So I can just continue down here until I get to 12. Okay, so 12 is going to be $8,048.79 is what it's going to round up to. And then if I went to 20, let's see what we get for 20. For 20, we get to $12,828.54. That's going to be your 20. Okay. So now we're going to make a sketch. And for the sketch, let me do this. For the sketch, we're going to have make an L-shaped graph. And this is going to be the number of years. And this is going to be dollars. And it is a sketch. And one thing for these graphs, we always have an asymptote for these graphs on the x-axis, which is y equals 0. And then this graph is an increasing graph. So it is going to be starting at 4,000. I'm going to write 4,000 here. And it's going to be increasing. And there you go. That's going to be my sketch. Now, we have Simple Sally, which is the letter D here. She has a better offer. Instead of the 6%, she has 9%, but it's simple interest for 12 years. Okay. What investment should Jose take to make the most amount of money? Okay, so if we're keeping it for the 12 years, let's see what's going to happen. So simple interest is different than compound. We're not multiplying every time, we are adding. What we're doing is we're adding 9% of our start. And so let me just kind of zoom in here. So we are starting with 4,000. We're starting with 4,000. And we're going to find 9% of 4,000. So I'm going to times it by 0.09. And so when I do that, I'll just move this up a little. So when I do that and I put in 4,000, 4,000 times 0.09, I end up with $360. So every year we're getting $360. So our equation is going to be y equal 4,000. But instead of multiplying this time, we are adding 360 x years. That's going to be our equation. So if we want to find year 12, I'm going to be putting 12 into this equation for my x. So I'm going to go 4,000 plus 360 times 12, and I'm going to see what we get. So 4,000 plus 360 times 12, we end up with 8,320. So up here for year 12 at the 6% compound interest, we had 8,048. Here for 12 years at 9% simple interest, we have 8,320. So for year 12, the simple interest at 9% is better than the 6% compound. Now, let me see what happens if I go to the 20 year like we have here. So this is what we had for 20 for our compound. And let's see what I get for 20 here. So I'm going to go 4,000 plus 360 times 20. And I'm just going to come steal this and change this to a 20. And I end up with 11,200. So this is what we have for year 20. My other one is 12,000. So what I'm going to say here is that, and I think I'm just going to type this. And make it bold. Okay, so the simple interest at 9% is better for 12 years than the compound interest at 6%. But after 20 years, the compound interest is better. Okay, so again, we want to pay attention to understanding the difference between simple and compound interest. Compound interest is multiplying. It is exponential. It is geometric. Simple interest is linear. It is arithmetic. You're adding. Okay, so now let's look down at these ones. So on these ones, we're going to write an equation, and the equation we're going to write is going to be of the form y equal a times b to the power of x. And a is our y-intercept, and b is our multiplier. That's what we're timesing by. So in this problem over here, my y-intercept is 7. So that means my a is going to be 7. Now, if I am trying to figure out when I'm timesing by, if I was to make a table here, my 0 is 7, my 1 is 3. And so what happens is I took 7 times something to get b. So I have this equation right here. Oops. This equation right here that I'm going to try one more time. This equation right here that I'm going to be solving. So I am going to be solving that. I'm going to divide both sides by 7. So I get 3 over 7 is equal to b. So this equation is going to be y equals 7 times 3/7 raised to the power x. That's my equation for letter A. On letter B, again, where our y-intercept is 7. So our A is going to be 7. Now, in this case, this one's probably a little easier to see here. So my 0 again was 7. My 1 is 21. So what am I doing? So I am timesing 7 by something to get 21. So in this case, my b is 3. So my equation is going to be y equals 7 times 3 to the power x, and that's our equation. On number 3, okay, says more seagulls. The number of seagulls at lunch is equal to 5 times 4 to the power x. Assume x represents the number of days, okay? So how many seagulls were there in the start? This 5 is how many seagulls there were. So there's 5, okay, again, because of this right there. What is the multiplier? The multiplier is this 4. So that is our multiplier, okay? How many seagulls are there on day 5? So to figure out day 5, I am going to put 5 in for this x. So we're going to go 5 times 4 raised to the power 5 equals, and I'm going to put that into my calculator. And so 5 times 4 raised to the power 5, we end up with, 5,120 seagulls. When will there be more than 1,000 seagulls? So I want to know when this is going to equal 1,000 or more than 1,000. So what we can do is we can sit here and kind of guess and check. And I know raising it to the power of 5 was too much. So I can just raise this to the power, let's say I raise it to the power 3. Okay, that's not enough. Let's say I raise it to the power of 4. Okay, so it's somewhere in between 3 and 4. So in between 3 and, well, I'll say this. So when will it be more than 3,000? By day 4. Okay, day 3 was not enough. Day 3 was 320, but by day 4 we have more than 1,000. So by day 4. Describe a situation that goes with this equation. So for a problem like this, you're just going to kind of make up a little word problem. So today at lunch, there were 5 seagulls. Every day, there are 4 times as many seagulls. So that would be a situation that would use that equation. Okay, so on these problems here, when we have something raised to a negative power, okay, anything raised to negative power is equal to 1 over that to the positive power. Or in this case, just 1 over m if I'm doing it like that. If I had something like, let me do it in a different color, m to the negative second power, that would be the same as 1 over m to the second. If I had something like this, let me do this in a different color. Let's say I had the following. Do this. Let's say we had m over n to the negative first power. That would equal n over m to the first power, which is just going to be n over m. So raising something to a negative power makes it into a reciprocal. So when we are dealing with 8 to the negative first, that is going to be 1 over 8. Don't put it in and get a decimal. Leave it as a fraction. This one here, 5 halves to negative 1. Again, that negative 1 is going to make into a reciprocal. So we end up with a 2/5. On C, I am going to be flipping this because of the negative, but it's still being raised to the third power. So what happens is my 3 is being raised to the third and my 4 is being raised to the third. 3 to the third is 27 and 4 to the third is 64. And that would be my answer. Okay. So on the next set of problems, we are going to be asked to make a sketch of this and answer these questions, okay? So we are trying to graph this. So this is an exponential. All exponentials are going to have an asymptote on the x-axis at y equals 0. So asymptote y equals 0. My y-intercept is going to be this 0.7. So this is going to be 0.7. That's my y-intercept. So let's say I put a point here, and I'm going to call it 0.7. Here, I'm going to actually write it on this side. Then we're going to look at this multiplier, that 5. Okay, that is our multiplier. Since that is a 5, which is bigger than 1, this is going to be increasing. So my graph is going to start lower, go through, and increase. And that would be our graph. On 6 and 7. So on 6 and 7, we're trying to write an exponential. So it's going to look like this. Okay, for both of them, y equal a times b to the power x. Now this point right here is nice. That is a y-intercept. So why is that nice? You know your a is 2 automatically. So then we have y equal, instead of my a, 2 times b to the power x. And then what we're going to do is we're going to put in this other point for our x and y. So I'm going to get 450 is equal to 2 times b. I'm going to write like this, 2 times b squared. And we're going to solve. So when we're solving something like this, we need to divide by 2 to get our b squared by itself. And so I'm going to end up getting 225 is equal to b squared. And then I'm going to take the square root of both sides. And so when I take the square root of 225, I'm going to end up with, so the square root of 225, I end up with 15. Now, really, we have a positive and a negative 15, but for exponentials, your b can never be negative. So our equation is going to be y equal a, which is 2, times b, which is 15 to the power x. That's our equation. On 7, similar idea. Okay, it's just in a table form. So in this case, this is going to be my a. Okay, my a is going to be 250, because that is our y-intercept. And I need to figure out what I'm timesing by. So basically, this 150 is going to be 250 times something. So that's the equation I'm going to solve. So let me just write it out here. So I'm going to be doing 150 is equal to 250 times b. I'm going to divide both sides by 250. And so take 150 divided by 250. I end up getting a 0.6. So that's my b. That's what I'm timesing by. So our equation is going to be y equal a, which is 250, times my b, which is 0.6 to the power x. Okay, on 8, so they want us to answer these 4 questions. I'm going to zoom in a little bit on this. So x-intercept, that's where it crosses the x-axis. So this is going to be 4, or 4 comma 0 if you're going to write it as a point. This over here is my y-intercept. And again, as a point, this is going to be 0 comma negative 2. Equations of a line are of the form y equal mx plus b. My b is my y-intercept. So I know my y-intercept, my b is negative 2. Okay, so b equals negative 2. I need to find my slope. So I am going to be going up 2 over 1, 2, 3, 4. So my slope is going to be up 2 over 4, or 1/2. So the equation of our line is going to be y equal 1/2 x minus 2. Then they're asking us to figure out what is f of negative 2. So f of negative 2 is saying, okay, if we're putting negative 2 in for x, what is our y? So if I'm drawing a line through x being negative 2, this is everywhere x is equal to negative 2. You see it touches the graph right here at negative 3. So this is going to be equal to negative 3. Again, because I have a point at negative 2 comma negative 3. When I put in negative 2 for my x, I get out negative 3 for my y. Let's see, 9, a couple things I don't like. I don't like this. So I'm going to move that. So I'm going to have 2x squared raised to the third. I still have my x to the fifth, and I'm going to have my y to the second on the bottom. Second thing I need to do, I need to raise everything to power 3 on top. So 2 to the third is 8. And x squared, so right here, when I have my x squared to the third power, power to power, I multiply. So it's going to be x to the sixth over x to the fifth, y to the second. Then you'll notice that I have 5 x's here that are going to cancel with this, and I'm going to be left with an x to the I'm going to be left with an x. Okay, so 5 on the bottom, we're going to cancel with 5 from the top, leaving me with 1. So my answer is going to be 8x over y to the second. So let's see, number 10, they want us to find x when f of x is 4. So this is different. This is not f of 4. F of 4 would be me coming over here and going up and down and trying to see, okay, when x is 4, what is y? This is different. They want us to find x when y is 4, okay? So this means that y is 4. So if I go to where y is 4, this is where y is 4, right here. That's everywhere y is 4. And it touches the graph right here at 1, 4. So what is my x when f of x is 4? X is 1. C. So number 11 is very similar to the one that we just did on the other page. Okay. Do not like this negative exponent. So again, I'm going to rewrite this 5x to the second. I have my x to the third and I have my y to the 7th now on the bottom. So now that's going to be on top 25 and then x to the second. So x squared over x to the third, y to the 7th. So I am going to be taking 2 x's from here with 2 from here. That's going to leave me with 1 on the bottom. So I'm going to get 25x y to the 7th, which looks like B. So on 12, we're just solving. First thing I'm going to do is I'm going to distribute. So I'm going to get 4n minus 8 plus 5 equals 3n plus 9. Then I want to see, hey, can I clean up on this side? So again, this is all on the same side of the equal. Can I simplify? And so when I do that, I end up getting 4n minus 3 equals 3n plus 9. I'm going to minus 3n from both sides. I get n minus 3 is equal to 9. I add 3. I get n is equal to 12. So that's going to be letter A. Okay, so on 13, we're going to solve this using systems of equations, and we're going to use substitution because this one here, this is going to be the same as y. So I'm going to put that into this y in the second equation. So I'm going to go x plus y equals -1. So again, x plus y equals -1. X plus y equals -1. And my y is the same as 2x minus 4. So I'm going to put 2x minus 4. And now I'm going to combine like terms. Well, I can take away the parentheses, honestly, because I don't need those parentheses anymore. I can combine like terms and I get 3x minus 4 equals -1. I add 4 to both sides and I get 3x is equal to 3. So I get x is equal to 1. So I got x is 1. Now in this case, there's only one answer that had x being 1. So that's going to be it. But if I didn't have one, I'm going to put this into either equation. I'm thinking the top one's going to be easier. So y is equal to 2 times 1 minus 4. So that's going to be 2 minus 4, which is a -2. So again, this one was correct. On number 14, they're giving us a graph and they want us to find the point of intersection. So when they're asking you to find the point of intersection, you're going to, or solve the system, that's really point of intersection. You're going to look where the two graphs cross. They cross right here. They cross right here at this point. And this point is -1, -5. So D is our answer. question number 15. Starting with 8, then 2, then 0.5. So it looks to me like this is geometric. It looks like we're taking 8 and we're dividing it by 4 to get 2. So if you're dividing by 4, that means you're multiplying by 1/4. Now that would be to the power n minus 1. I don't see that as an answer. And again, why am I saying n minus 1? Because that's your first term, not your 0 term. So if you want your 0 term, we're going to be going backwards. So going backwards, I'd be timesing by 4, which would give me a 32. So that means I'm going to have f of n is equal to 32 times 1/4 to the power n. And none of these is a 1/4, but the same as a 1/4 is a 0.25. And my answer is going to be A. Okay, this time they want an explicit equation for this one. Looking at it, it looks like I'm minusing 2. So that means it's going to be arithmetic. Okay, so if I'm going to start with this 4, it would be 4 minus 2 times n minus 1. I do not see that as a choice. I could clean it up, or I can also go backwards. Since this is my 1, let's find my 0. So going backwards, if I'm trying to find my 0, I am minusing 2. So going backwards, I'm going to add 2. So it's going to be a 6. So my equation is going to be f of n is equal to 6 minus 2n. And so that's going to be C. "17, what property are these two triangles that make these two triangles congruent?" It's been a while since we've done this stuff. So you want to notice that this is a side, congruent to the side. So I've got a side. I've got this angle with this angle. So I've got angle. And then they share this side that I just drew in green. So that's going to be side. So it looks like side, angle, side is going to be our answer. And that is the last one. So hopefully this video and the other video I did for systems of, for as a D-Day is going to help you guys for our test that we're going to be taking next week. So study, study, study.